What's up, smart people, and welcome back to another tutorial video right here in the Calculus Storage channel. Now, to go ahead and jump right in this tutorial, we have a function h of x defined in terms of two other functions. So we have h of x is equal to g of f of x, and we want to go ahead and evaluate this function at x is equal to 5. Let's go ahead and start off by setting up our equation. So we'll have h of 5 is equal to g of f of 5. Now, the first step that we have to take to evaluate h of 5 is to figure out what f of 5 is. And so according to the table, at x is equal to 5, the value of f of 5 is 34. And so by updating our equation, we'll go ahead and end up with the following format. h of 5 is equal to g of 34. Now, at this point, all we have to do to evaluate h of 5 is figure out what g of 34 is. So the exercise actually tells us what g is. G is defined to be x to the third power minus 14x minus 27, all divided by x plus 2. Now, if you want to go ahead and evaluate g at 34, all you have to do is plug in a 34 wherever you see an x. And so by following this logic, we'll end up with the equation h of 5 is equal to g of 34 is equal to 34 raised to the third power minus 14 times 34 minus 27, all divided by 34 plus 2. Now, in this last step, all you have to do is evaluate this expression using the calculator, and rounding off to the nearest whole number, we get that h of 5 is 1078. Our final answer. Alright, so for this second part, we want to go ahead and evaluate f inverse at x is equal to 4. Now, the only issue is that the question only gave us a table for f of x. So we know that our inputs are 1, 2, 3, 4, and 5, and our outputs are negative 10, negative 5, 4, 17, and 34. So, to go ahead and evaluate f inverse at x is equal to 4, we're first going to have to come up with a table that expresses the inverse function f of x. And so remember an important property of inverse functions. To go ahead and formulate your inverse function table, all you have to do is get the input of your original f of x table, and that becomes your output. And when you look at your output for your original f of x equation, you'll go ahead and come up with your input for your inverse function f of x. And so following that logic, let's go ahead and reference the output values of our original f of x equation. And so our output values are negative 10, negative 5, 4, 17, and 34. And so those output values for our f of x equation are going to become our input values for this inverse f of x function. And so for this inverse f of x function, our input is going to be negative 10, negative 5, 4, 17, and 34. Now, let's go ahead and look at our input from our original f of x function. And so remember that by looking at our input for our original f of x function, this is going to be converted into our output for our inverse f of x function. And so since our input for our original f of x function is 1, 2, 3, 4, and 5, for our inverse f of x function, our output is going to be 1, 2, 3, 4, and 5. And so now that we've been able to come up with this table for our inverse f of x function, now we can go ahead and evaluate our inverse f of x function at x is equal to 4. And so by looking at the table for our inverse f of x function, When x is equal to 4, our inverse f of x function is 3. Our final answer. So jumping into the last part, we want to go ahead and solve for x when g of x assumes a value of 3. Now, referencing g of x, we know that g of x, according to what the exercise gave us, is defined to be x raised to the third power minus 14x minus 27, all divided by x plus 2. Now, if we want to go ahead and solve for x when g of x is equal to 3, we can go ahead and set up our equation in the following manner. 3 is equal to x to the third power minus 14x minus 27, all divided by x plus 2. Now, for this question, there are actually two ways of solving this equation. The first way is to use a graphing calculator, and we can go ahead and graph y is equal to 3 and y is equal to x to the power of 3 minus 14x minus 27, all divided by x plus 2, and analyze the points of intersection. Now, if you guys have access to those TI-84s or those TI-89s or even the TI-Inspires, those calculators will help you perform this function of being able to analyze the points of intersection. If not, you can always go ahead and jump onto Desmos and plot these functions out, and it'll go ahead and work out in the same way. And so by looking at this picture, right here we have our two functions plotted out. In red, we have our y is equal to 3 function, and in blue, we have our y is equal to x to the third power minus 14x minus 27, all divided by x plus 2. And by taking on this approach, to go ahead and find the solution x, all you have to do is look at the point of intersection. And in this case, the point of intersection happens at x is equal to 4.88. Now, for the second way that you can go ahead and solve this equation requires some algebra and a graphing calculator. And so we can go ahead and start with the equation that we set up, which was 3 is equal to x to the third power minus 14x minus 27, all divided by x plus 2. And so we can go ahead and algebraically manipulate this expression to gather all the terms on one side. And so by multiplying both sides by x plus 2, we'll go ahead and come up with the following expression. 3 times x plus 2 is equal to x to the power of 3 minus 14x minus 27, all divided by x plus 2 times x plus 2. Now, on the left-hand side, all we're going to end up with is 3 times x plus 2 is equal to x to the power of 3 minus 14x minus 27. And so at this point, we can go ahead and distribute the multiplication going on the left-hand side. And so 3 times x is 3x, and 3 times 2 is 6. And on the left-hand side, we'll end up with the same expression, x cubed minus 14x minus 27. Now, let's go ahead and cross everything over to one side. And let's just go ahead and cross over 3x to the other side by subtracting both sides by 3x. And so on the left-hand side, when you subtract 3x, those two terms will just cancel out. And on the right-hand side, by subtracting 3x, we can go ahead and combine like terms and combine negative 14x minus 3x. And we'll go ahead and end up with equation 6 is equal to x to the power of 3 minus 17x minus 27. And so to finish off, let's just go ahead and cross over 6 to the other side through subtraction. And so by subtracting the left-hand side by 6, we'll just go ahead and cancel those two terms out. And on the right-hand side, negative 27 minus 6 is negative 33. And so we'll go ahead and end up with equation 0 is equal to x to the power of 3 minus 17x minus 33. And so by taking our equation up to this point, we can go ahead and use a graphing calculator to go ahead and graph x to the power of 3 minus 17x minus 33, and we can go ahead and analyze the zeros for this curve. And so if you go ahead and notice, in this equation, our purple curve is x to the power of 3 minus 17x minus 33. And if you go ahead and analyze the zeros of this curve, you'll come up with x is equal to 4.88. The same solution that we got through our first approach. And so in whatever method you choose to use to solve the equation 3 is equal to x to the power of 3 minus 14x minus 27 all divided by x plus 2, you'll end up with the same solution, which is x is equal to 4.88. Alright, so if you guys have any questions, just go ahead and drop those questions down in the comment section, and I'll go ahead and see you next time.